A very warm welcome to our learners from all over the world. I can't see where you're from, but I see based on the names that you're already from different parts of the country and the planet, actually. So happy to see you. Curious about your questions. I've already peeked in a little bit within the system what will await us here. Yeah, Marcel Bilo, nice to meet you. I'm the host for today, but nonetheless, Uli is also here. Short introduction from his side. You already got to know us a little bit by following our course. And yeah, within the next hour, we would like to share first impressions, answer a couple of questions we already got from you, and get a feeling a bit about what you're doing. Maybe there's also some time that you can share critics or things you haven't understood entirely, or what to come. So feel free to join a lively discussion, but we will start first with a couple of things we already got from you learners. That might be actually that is question from you or someone else, but let's see.
So, if I could chime in, we've got a couple. I went through the assignments that you guys submitted and came across some common mistakes, common questions. I really appreciated the discussions that were happening between people with different expertise and starting to discuss maybe we do it this way, maybe we do it that way, but maybe we find out from the source exactly how they would approach it. And then maybe that can also lead to a discussion between them two as well. Yeah. So
So,
assignment
so,
one,
so we, so we are the source.
the source for the course. That's for sure.
And so through the course.
I never,
Perfect.
never saw myself like this. Interesting. Okay, go on.
Yes. So this is like a little review of the main questions and main common mistakes. So first of all, the difference between what kinds of dimensions there are of design intention and how to dimension for the design intention rather than what's actually being built. What the standard practice for choosing a section plane, for instance, through a conical piece or through a circular piece, where do you choose that section plane? When you have repetitive components, what's some different approaches for how to dimension those and detail the intention behind the project? How to incorporate tolerances and how that might change the implications of the detail and how it will later be manufactured. Is kind of the summary. And we have a couple student examples, took the names off, but I believe everyone kind of has access to SketchDrive. You can probably figure out whose they are, but took the names off. If we're using your example, it's purely for educational purposes, so that way we can discuss what happened and how they might approach it differently so we can all learn.
Yeah.
Yep.
Yeah, perfect. So it's not our intention to blame someone. We are all here to learn,
Mhm.
and we are especially known for creating a safe environment in which you can learn from your mistakes. So, Uli, will you start? Will you pick one? Do you have a favorite question already to answer?
No, 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 no. I just dig into it, and I just actually take myself notes for our next how to detail,
Okay.
especially the question about whose fault is it.
Yes.
That's an interesting one as well, which we have to answer somewhere later today as well. So
Yes. Yes,
no
those
direct
questions.
those questions, no direct preferences. What the difference between the
Yes.
design dimensioning as built and as
Hmm.
built dimensioning? I'm actually not sure what this is about.
Well,
So
I
do
have an
you get it?
example.
Yeah.
I have an
Perfect.
example about where this might have occurred. So, for
Yeah.
instance, there was some discussion in the forum about this one, about how to intentionally dimension the bricks because this project is like a reused brick project.
Hmm.
Because of that, the bricks are all different dimensions. So there was a little
Hmm.
bit of discussion about how to dimension the intention behind the project, whether it's important to specify the exact brick size, the joint size, or the total row heights.
Yeah. When
Yeah.
I would look at this, I would say if they're so different types of bricks, you either go for the super complex version, scan each brick, and ask an AI to reassemble them in a perfect setting, which is very, very techy. The alternative, more simple, I would suggest to do is to get a kind of a feeling about the rough general dimension of the bricks and then make a grid setting. And then with the mortar between the bricks, you're able to adjust the different sizes. So you have a grid setting And then the bricks are mainly taking their positions in this grid setting, and then with the mortar you change. When you look at, say, custom-built natural stone walls, they do something similar. And
I would
actually, you're right, Marcel. You are the bricklayer. You should talk.
I would say I've grown up as a father of a plumber, but I learned bricklayer after school. So before I became an architect, I wanted to build houses, and I've spent 3 years on the building site. And actually, you already mentioned the mortar is in principle what keeps the tolerances. So I think you have to pre-select a little bit, because what we usually do within a wall when we have the mortar as the interface, sounds weird, but the layer in between that takes care of all of the tolerances, you assume that your bricks you have from one company, from a charge, and based on the making process, sometimes if they're more outside of the kiln, sometimes inside, they shrink or have various curvatures. So therefore, they are within a range of dimensions, let's say plus minus 10 millimeters. Then you can set up everything and the mortar layer will do. If you have, for instance, now reclaimed bricks that are from various sources and from various formats even, I think you have to sort of pre-select them a little bit. And maybe you can do so in the layers. So if you have the 6 to 9 centimeters would be one layer, and then you can adjust that. And then with a new mortar layer, you can maybe have another sort of stones which are 10 to 11 or something like that. But the mortar in between, if you design them in a way that they are 10 millimeters or so, you have to make sure that you're within that tolerance. You can deal with that. If the stone itself is already 2 centimeters higher, a 10 millimeter mortar layer doesn't help. So therefore, I think it's a little bit of sorting, and you may also have to accept that the mortar actually varies in sizes because it accommodates different heights. Might be playful, might look also interesting, or you have to hand sort them a little bit more, which will take more labor and makes the entire thing more expensive, I would say.
So given all of that, how might you translate this on a detail drawing to make it clear your intentions, maybe maintaining the row height?
Center lines, Marcel.
Yeah, I think that you are able to describe things. Maybe an architecture office can already play a little bit around with a couple of stones, different formats to give the craftsman a intention what we want to see, and then they can play alongside, I would say. I think in this sort of reusing, repurposing approaches, you have to give the craftsman a little bit more freedom. As long as you stay within the overall outer exterior dimension. So we see this triangle, for instance, there's 800 and it has a height of 425. That's what we want. Inside, let to a degree of freedom decide the bricklayers, the masons, the craftsmen to do their job. They can maybe be being guided by, we need that red color pattern, we want to have a half overlay pattern whatsoever, but then give them the freedom, I would say.
You go for drywall structures. So natural stone being adjusted, things like drywall, as fences for cattle or things like this. There's even no opportunity to give it a grid. So what is made there is to define that you try to create a horizontal line every 50 centimeter or every meter to give it at least some kind of geometry which looks equal, but then you allow in between whatever is necessary, and that's another way to deal with it. So if this is a repurpose activity and you're not able to have this precise measures, well, then you need to deal with it, and then you need to give boundaries.
Yep.
So perhaps the fact that the intention behind this design is not to replicate the exact same bricks if you wanted to replicate this, but so you should not dimension each brick's individual height, but you should dimension the target goal of each row and then provide tolerances like that.
Or a bunch of rows.
Yes.
Yeah, precisely. I would also say so. Good.
All right, that makes sense.
Makes sense.
Any questions from the people listening in on this?
Audience thinks that makes sense. I like it.
Yeah. All
Go
right.
on,
Okay.
shoot the
Um,
next.
This one was about a candle. And
Ah,
as you can see, the vertical section was taken at an arbitrary point to show the difference between as they explained, was that they chose a spot so that way you could see that it's conical in the background. But I was curious if you guys have knowledge on the standard practice for such conical shapes. What makes more sense? Is this standard practice or?
Where would you do the horizontal cut in this detail?
Yes. Mm-hmm.
In say construction practice, we
Mm-hmm.
select a level where we try to cut as much as necessary and possible different settings. So let's say in the European environment, we cut somewhere in a meter's height. Why is that? Due to the windows being integrated in walls, this meter always cuts through the window as well as through the normal wall. If you would go for something 20 centimeter above floor level, you just cut the normal wall. So
and you only see the doors. Yeah.
and you see the doors. But if you cut in a meter, you see doors, wall, and windows. So we try to cut somewhere where it is meaningful. And
In this
yeah, go on.
in this case, because of this candle, it's just a product design. There is no doors. There is no right or wrong where to cut. So what you are interested is, for instance, to make sure that everyone understands that this is a circle from a top, that this is how do you
Mm-hmm.
call it? Centric, symmetric,
Yeah, circular, yeah,
circular,
rotational symmetry. Yeah.
rotational symmetry. So you have to make sure that you show the contour of the element and then the center of it. And in this case, in a horizontal section, I would say maybe even a top view and a bottom view will help more, because the conus itself is a matter of where you cut it. The height defines the diameter at that place, and therefore you don't get any more information out of that. It's
Mm-hmm.
in this case a very specific demand or product shape that defines a little bit. Yeah, you have to deal with your own. You have to. I don't think that there's any standards in product development where you. My former professor Althaus always said, deliver all the drawings that is necessary to make this thing. That the company, for instance, looks at it, he knows exactly where the angle is or what the angle is, how thick the bottom is, the material thickness of the side walls. These measurements are very, very important. And for this symmetrical element, almost everything is shown in the vertical section already.
Mm-hmm. For
And
the
actually,
vertical section, yeah, sorry, Uli, you can continue.
say making the decision of where to cut a room in a horizontal, that's the same comment as Dirk Althaus at that time said. So if you cut in the meters in the meter level, you hit the most problems you want to solve.
Yep.
So it needs to make sense.
Mm-hmm.
Yeah, precisely.
With that in mind, for the vertical section, is there a standard practice for how to cut through a circular element vertically when you're looking at it that way? Would it make more sense to go straight through the middle, or?
I would always do, unless there's nothing happen on the way down. There's the lid with an overhang, and then the conus, and then the bottom. If there's nothing happen, it almost doesn't make any sense to show somewhere a cut. The moment you imagine this would be a candle holder with a little handle, then you would like to see additional information on where the handle is fixed and whatsoever. So you might also unveil how the handle is made. Is it hollow or not? That might define a section height to cut. But in this case, if it's just such a simple product, I don't think that there's any rule in that.
I'd like to address this. It actually is an interesting question, because when you think about we draw these sections, these floor plans, to explain the construction. You explain what we see. So yes, it makes sense as it is cutted here, even the floor plan with, say, dotted line where you identify, okay, this is top. So when you think about the drawings we do in our project, we cut somewhere at the top part, we cut somewhere at the horizontal part. The next step of advancements would be digging into the corner detail and identify if the corner itself also changes something. Yep. And so we make the decision to detail what we need to detail, so that it in total explains the construction with all its complexities and fits to each other. And it always, when we think about detailing something, it always makes sense to have a simple section where you're cutting the main system, but then you need to dig also into the, say, advanced situations where things match other interfaces, where things are linked. So the decision, there's no common standard to say you have to exactly cut this way, but the decision is the designer's decision to showcase the whole complexity of the detail. If you want to go for, say, realizing it. Cut. Side note, if you try to fake something, if you try to mimic something, you may make a general section and don't investigate all corners, because this is then just the, say, principle of how you think things are made. But then you may let it to someone else to go for the next level of the details, which is not what this course does. So this course goes into really making the details to the level that they can be used for manufacturing.
One more thing to think about, and then we will stop with this question here, is, for instance, we had a sunshade developed for my students within the Bucky Lab, and they had a spherical, huge ball with a material thickness of 25 millimeters, something like that. And in the vertical section, you can see the material thickness. If you cut horizontally at any given moment onto that sphere, you only unveil the material thickness at the perfect center point of the equator. Otherwise, the projection of the horizontal section unveils a thicker material. So therefore, you may also think about giving an overview of perpendicular following the contour. Otherwise, it looks thicker, especially if you start at the very bottom. Then it looks way thicker for the material thickness in the perfect parallel projection. So therefore, be also careful that you don't give a false impression about the material thickness. A vertical section through would then be easier to read.
Yes. So for instance, with this example, if there were two lines drawn on the candle wall, at this section point, they will be a little bit wider than they actually are. But if it was cut straight through the middle, then it would be the true dimension of the candle wall. That makes sense?
In this case, for the vertical, yes. In this case, it will also,
for the horizontal, not so much.
The horizontal section shows a little wider because it's the projection, what you see.
Yes, exactly.
Good. Okay. Hopefully that helps a little bit in defining the right position of sections. If you're unclear, make a little isometric view next to it, showcase what you're doing, and maybe you have to draw one more detail in order to make really sure that they don't have to call you, hey, we're standing here on the building site. What do you mean?
Yeah, avoid expensive calls like that.
Yeah, precisely.
Yeah.
Whose fault it is.
Yeah. Who, any students have any questions about this? Otherwise, we'll move on to the next one.
Precisely. Raise your hand.
All right.
Something like that.
Cool.
Perfect.
So this next one comes from a student as well, where there was some discussion in the forum about how might be the best way to dimension the intention of these holes. What's most important? Is the size and the spacing of the holes most important, or is there a certain number within a certain distance that needs to be achieved, or is it more important that the holes are lined up next to each other? And with that in mind, tolerances, how to add that into the drawing, and what kind of impact this will have on the shop drawings for the manufacturer later.
I would say this is pretty much up to the designer. So when I look at this, I would expect that the person designed this wanted to have the holes exactly in one line, and then the rope being maybe the less perfect, precise position. If the designer wants it in a different, if say the whole design is expected to be more freeform with kind of coincident positioning of holes. So if you want this being perfectly in line, I would draw a center line and then again repeat the distances with center lines, and by the center lines define where to start to drill. So again, it pretty much depends on what you want to achieve. If you want to achieve the outer layer of the hole being exactly at one line, you may need to define that. If you want to have them all in equal distance to each other, I would go via a center line as a setting, and then maybe different dimensions appear, but they all center lined. So what do you think as a craftsman?
Me too. And I also would make sure that I mark and measure or dimension the center of the holes and then the diameter of the holes.
Yep.
So it's in principle a dotted line. You don't measure the spacing, the diameter, the spacing, but I would always go center to center. That's the more precise, and also for cut tools later on, if you have machines that do the drilling, they need to know how much apart each of the center of the holes is, and then it's the question of the right drill bit to define the diameter. Tolerance in this case can be mentioned within the little drawing stamp itself. We have a standard following a building code according to the nationality. In metal, we have different codes for standards than in, for instance, concrete. Just be aware that you don't apply concrete tolerances to metal because they will laugh at you. In metal, there's
that's what we do when we go to the details.
Precisely.
Oh. All right. Yes, this makes sense. Any other questions about this from the students? I saw that there were some in the chat.
But that's mainly about audio. So
precisely.
Awesome. I didn't look at the chat yet. So
I hope that Anjui is able to listen to us.
Yep.
It seems that for everyone else, the audio works. So therefore, hopefully.
Yeah, you go on.
All right. Well, then we'll go on. We'll move on. So next we have some other questions, which is what was taken out of the discussion forum. Summarized is that there are many different people involved in facade design. So who is liable when a problem occurs? Maybe we can discuss the different examples of who might be liable if this happens or if that happens. Then other questions in that was also, how are free-form shapes accomplished with the stick system, which I think we'll be addressing later as well.
Yes.
And then when is a stick system typology ideal for a facade versus others, was kind of a follow-up to the free-form. So maybe we can just begin with the first one right here. I don't have any more slides, so we'll just look at this.
Fine. So for who's responsible, who does do work and get paid for, takes responsibility. That's say a principle common for all engineering work. Different environments, different countries have different legislation on responsibility you take. So that's always something which you need to, per contract and per project, need to identify and agree. And then there's different levels of detailing which are required. So in some areas, in some countries, you may start with a very global design. You bring it to a certain level, defining outer geometry, not thinking about how the building itself is made, how the facade is made by the design team. And then it's handed over to a general contractor who then comes with suggestions and makes decisions. And obviously it's clear that in this setup, the general contractor and his subcontractors take responsibility for the parts they do. So if then the facade is leaking, this responsibility doesn't stay with the general design team, even if you're then part of the general design team as a facade consultant, because you mainly give a typology of facade, a grid of a system, and then see what the general contractor does, which means liability lays then there. And yes, you as a facade engineer also can work with a general contractor's environment, either within the general contractor's environment or with the facade construction company. And there you take the reliability for how to make it, again, water tightness if requested, and then it's possible to be done on site. So liability here is pretty much with, say, the contractor. If you go for the extreme opposite of working, you go with, say, specific tender documents for specific tasks. And Marcel and me are going to have at the end of this course this kind of discussion as well, who takes what kind of reliability. And even two of us proved in this project that we have to take some reliability ourselves, which means, okay, you have an architect designing it, an engineer, continuing facade engineer taking down all the details to a one-to-one level to make sure that even each screw and bolt and every fixing is known. And then construction company comes, not a general contractor, but facade construction company comes and takes this and really installs it this way. And then you, as an engineer, take all the reliability that really is going to work by defining the rubbers, the glass, and the system, which needs to be reflected in your fees you gain by this, which then means, okay, you take this responsibility. And then you nicely dig into the situation that, say, if something fails, everyone is pointing at everybody to identify whose fault it is. It's impossible for such a global course to come with, this is the only really way to address who's having responsibility. But the general comment would be, the more you draw, the more you take responsibility, and the more you need to also get paid for.
I may also add a little anecdote we have seen on a project we were involved in. That was the color. Here, the cladding isn't the correct material. We had an issue with the wrong color. So we had a stick system designed, and there was the intention of the architect to have 6 different colors being visible all over. So we thought, and it was our intention within the planning, that the cover caps were the same color as also the infill panels. So there's a solid panel, and then there comes an openable window, and then a smaller openable night ventilation window on top. The bottom and the top part were solid metal sandwiches in the same powder coating as the cover caps. So we thought that everything was clear in this, and we have built the models like that and whatsoever. At a certain point, there was a discussion about cutting costs down, and our boss back then decided not to have a mock-up. Mock-up being a one-to-one scale, maybe 1 or 2 grid wide facade prototype that's built as intended and described in the documents, and also with the right materials / colors. So therefore you might figure out that, oh no, you wanted that natural stone polished, or it has to have a rough cut sawn surface. That's where the architect and the construction guys and also the contractor can have a little last word about this or that. If we would have seen what later was delivered, a gray cover cap all over, and then a infill with the patterns of these 6 different colors, we would have directly yelled at everyone, who could this happen? We have sent these little wonderful drawings. What I figured out after I saw the truck arriving and I put my hands on the head, so, oh, what went wrong? I just figured out that we had communicated with the facade contractor with a fax machine. A fax machine back then was black and white. So therefore, all of our wonderful, colorful drawings went through. At the very end, the contractor made his own drawings and just added little texts with RAL color codes. RAL 2016, oceanic blue. RAL 2015 in turquoise green, and then RAL 2025 apple green. And they were also a little bit unsharp, and we just passed in a hurry through. Everything looked nice. We checked the dimensions, we checked everything else, but we haven't looked at our little card with the colors. And this was something we haven't figured out due to the way that we communicated via fax. Nowadays, you send each other colorful emails in PDF and whatsoever. You would have seen directly. Happens.
Sure, I'm not sure. This say little comments also may disappear on a digital drawing. Yeah, but the point is Marcel is addressing this. So in that process, the contractor changed the color, and you as responsible facade engineer should have seen it.
Yep.
And that's say then the fault situation. Should the contractor have said that they change color? Yes, they should. Should you have seen that this color is changed? Yes, you should. And here we go. That's a good interesting discussion. And that's actually doesn't matter if it's on facades or whatever kind of project.
But what I would say is that a mock-up, for instance, it had maybe cost 10,000 euros. to have it over there, to have everyone involved. In this case, it was also a bigger project with many, many different customers and clients later on. So it would have been very clear that there was a miscommunication, for instance, within the coloring of these elements. And then everyone would have seen, and it would be easy to talk about. If you do have a mock-up on the building site, beforehand you start producing the facade panels, you could directly see differences in materials, in colors, in surface qualities, and then it's easier to communicate. Later on in a drawing, things might be overlooked, and then you have to deal with that. In our case, it was our mistake. We haven't checked that, and yeah, the communication was apparently not that clear from our side, and we haven't double checked it, and therefore we had to live with that. Otherwise, they had to produce the entire facade new, or almost new. So therefore, no option. We accepted as it is. Was our mistake.
Mm-hmm.
Yeah.
Yep. Cool. I'll also say I've experienced that in my little bits of internships as the intern, going over the drawings and comparing them to what we said and finding little things that have changed, and then having to talk to the supervisor about it, and then they have to make a call. But yeah, to avoid liability. So yeah. Anyways,
I really like the. I think we have to answer the next one about the freeform shapes, isn't it?
Go on, Marcel.
That's an interesting one. This is a lovely story when all the technologies that we are right now have within our tool belt comes to play. Back then, freeform shapes could only be as a polygonal approximation. Means you approach a circle with sticks and you end up with a stop sign. A hexagon, an octagon, and then you discuss with your clients, how round do you think it is? Is a hexagon or a octagon already round enough for you? At a certain moment, he will say yes or no, but you have to figure out how to do that, because a stick system comes as extruded profiles of a length standardized at 6 meters. Means if you want to approach a slightly curve, you may end up with stick lengths of 1 meter in a curved way. So therefore, there's a sort of a polyline that follows this with straight lines, and that might already solve the problem. You can also think about bending profiles, which then becomes very expensive. You are able to roll profiles of any kind from windows and or stick systems in a larger radius. That becomes expensive, and then you also have to deal with the glazing. And most likely what we see is in bigger glass spheres, in shell structures and whatsoever, is that we see a triangulated surface of straight sticks. And nowadays we can even make the nodes that join the various incoming straight profiles with three-dimensionally freeform as a 3D printed node. We have seen this. Uli has supervised PhDs in his chair in Darmstadt from aluminium, from steel. We see this on various attempts, and that is nowadays becoming more and more available and also affordable, let's say, within a bigger project budget. But Uli, tell us, what's the latest stand?
Yeah. You're hitting the points. And actually, in another program which we are currently developing, which is about innovation in this MicroMaster program, so not this course, but another course, there will be also some shots on, say, these 3D printed nodes for stick systems in freeform. But Marcel is super right. That's the skeleton, and then you have to somehow do the infill. So the infill is in a freeform geometry with glass, which is manufactured flat. That's a complex one. So 2 ways to deal with that, for example. You either do them warm bended, which means you heat up that glass to 800 degrees, let it fall into a form, which then creates this freeform surface, like we use in front shields of windows or of cars, for example. The front shield of a car is always kind of bended. Or we do this cold bending, which means we just push a surface to a certain geometry. It has its limitations. You can't bend it infinite, very limited, but you actually can do this kind of cold bending as well. That's for glass. Then the concrete thing, when you want to have, say, a surface, a free-form surface in concrete, now you need a mold, which is able to be adjusted or being milled or being manufactured by timber bits and pieces to this geometry. And that counts for others as well. Metal, free-form bending, also an interesting one. If you bend it monodirectional, so like this, then it's quite simple. You may even fix it, and then it is. But if you want to really get it three-dimensional bend, well, you see it's already getting wrinkles. That won't work. So then you may need to do mechanical treatment. Incremental sheet metal forming is the scientific word for this, to secure that kind of free-form structures are appearing. Two-dimensional curving is a lot simpler than three-dimensional curvature, because three-dimensional curvature within the material itself creates additional stress.
Yeah, but usually for a stick system, you will always end up with straight sticks and then sort of nodes, however, 3D printed, machined out of a massive aluminium, or somehow put together with shifter nodes. Back then, this was the standard practice, that you end up with shifter cuts that, like in a wooden construction of a roof, that joins the angle to a very point. And then you have a straight cladding material, usually triangle insulation glass or single glass, depending on the quality of the desired roof structure, for instance, or facade.
So with all that in mind, if you had a free form geometry, would you immediately go for a stick system, or would you suggest a different kind of thing?
Depends, which is you're drifting us to the next question.
I am.
Fine. On purpose, we didn't go for the free-form version in this educational project. Let's say next level. So this one is pretty much about understanding the principles of detailing. When does it make sense to?
Yeah? Just one more. We can highlight from the previous MOOC about.
You're right.
We have in the previous MOOC where the Uli and I travel around with the camper van, we have the project in Rotterdam here, the show depot. Yeah. And in there you can see the engineers from ABT explaining us how they made these double curved, polished, mirrored glass panels. And the substructure behind is just pointual, but it's not a stick system. But it shows a little bit of the effort, the drama, the challenges that you have to deal with if you want to create a freeform shape. And that is only a sphere, and it's the most simplest freeform because it's at every place it's the same. Almost.
Next topic she wants to talk about. When does it make sense to have a stick system? We have within this MOOC we explained that stick systems in aluminium or timber or steel make sense, and we also argue that due to the strength of steel, stick systems in steel mainly make sense for very high or wide structures, while aluminium and wood are more for the smaller dimensions. That's the one aspect. And if you get it even smaller, you may end up not going for a stick system, but for a window system, which is a different setting of how the geometry is made. Or alternatively, if the construction site needs this, you go for a unitized system. And again, Marcel, unitized system we did show in Frankfurt, didn't we?
Yeah, we do.
So again, back to the previous MOOC, facade complexity explained simple. There we videotaped one project in Frankfurt where it was exactly about this decision to have a stick system at the lower part of this high-rise and then a unitized system at the higher part of the high-rise. And the reason for using a unitized system there is mainly logistics. So with a unitized system, you're able to, without a scaffolding in front of the building, are able to place all the units, so facade next to each other, in a faster and simpler and easier accessible way, which is a way to make a decision, which is not by, say, technical performance of the facade, but by logistic of the site, which makes that an alternative. And if we go back smaller versions. Instead of, say, having a 6-meter stick system, you may end up with a 2-meter height structure. And then the stick system becomes maybe a bit more expensive than a Windows system, because there are more companies, wider companies, which are able to deal with Windows systems. You may even end up with a PVC, a plastic version of that, and then you may end up with a Windows system, which means it's a window frame plus the window itself, which then tilts, which closes as an alternative. And that's why we picked in this exercise, and I think I already saw that, this 6-meter high setup, so that there's, say, the need to come to a certain dimension. Marcel, you want to comment? I see it.
Yeah,
the normal thing. Come on, hammer me.
In general, I would also say stick systems, 3-story high buildings, something like that, because you have the bottom layer that is attached to the ground. Then you have a standard floor, and then the top already including the roof. That makes sense for a stick system. The more layers you get on top, the more elements you have that are the same, the easier you might actually apply a unitized system where speed and logistics on the building side will increase. So therefore, also for commercial buildings more than for residential buildings, it's also the question of glazing. Usually we have stick systems in buildings that have glazings from floor till ceiling. In residential houses, maybe the first floor entrance or whatsoever might be stick systems, and then you continue with others, or maybe even with a punctured hole and window systems then. So it totally depends, but I would say it's more used in commercial buildings than in residential buildings.
What else can we comment?
There was also questions on the
chat.
The comments. There's a nice one that was how should we draw the detail and dimension of freeform shape to address all the necessary information required for construction? That's a thing of our future, and I would say a digital model will be almost impossible to avoid. So therefore, what you do is you define standard systems, the nodes, the system itself, how to clad and whatsoever. You can make a couple of drawings that shows the details of intersections with doors, with openings, with whatsoever, but the overall dimensioning and the overall shape of the building would not be able to come to explain via shop drawings as printed one in 2 dimensions. It doesn't make sense. So what we have is we have a bunch of standard 2D drawings that show the joint of the standard system you have picked, the joints and whatsoever, the doors, the windows, the openings, and then you always work in a joint BIM 3D model. And that's the only thing you have to control, sort of. That's the only way of doing that. And then we also have to deal with a new sort of profession that is the freeform guys, that is the digital fabrication guys. There's people who work sometimes within the architectural office, sometimes also as an external expert that help the manufacturers, the facade constructors and contractors to translate the architecture wish into a producible shape and form. So they might be the one who spit out the 5,000 item list of straight mullions with a 74.5 and this 36.7 degree cut, something like that. But it can't be on paper. It has to be a digital shape, I would say.
Marcel is talking as an expert because he was next to doing the shop drawings we show later in these videos. He also was doing exactly this kind of, say, data files for companies to cut their geometries. And here we are really linked to the software and the capability of the designer to be able to have that direct flow from, from the BIM model towards the manufacturing. And again, responsibility is also an interesting one. So who is responsible if someone in the beginning of the BIM model made a mistake and it doesn't fit inside? That's it's nothing. That's also an interesting discussion you easily can have.
Yep.
Annabelle, shall we go for the next question? Wondering if Dr. Knack and Dr. Biele could classify hempcrete balloon frame as a stick system. That's
I'm
super
curious
interesting.
to hear this answer.
Yeah, for sure not.
And that's pretty much a question of definition. So
Yeah,
Marcel and me, we are, say, in this field of education since quite a while. We also stick systems, say, as an English tongue wording is something which we use. We also used the stick and rail or post and rail system for a while. We ended up with stick system being the right wording.
Post
When you
and
think
beam
about
system also.
post and beam, when you think about, say, ventilated facades or curtain walls, which are words which are, say, drifting in our environment as well, we had intensive discussions of identifying what are the correct ways of saying. A stick system could also be a curtain wall, but a curtain wall could also be a fully glazed one. And we came to the conclusion we better don't use curtain wall because it's a more global comment than say stick system versus unitized systems. So wording is a super important aspect. Balloon frame. Well, the American balloon frame has a clear link qua logic and how it is made to stick systems, no question. But balloon frame systems are load bearing, while stick systems are non-load bearing, which is the main reason which I would take to not have this being the same. But when we think about balloon frame systems, and if hempcrete as an insulation is in or not, that's, say, a second discussion. When you think about where this traditionally comes from, you come to the European timber stick buildings of the Middle Ages. So that's actually something which is quite equal. Again, the stick system as a skeleton was the load-bearing main structure of the building, then closed with whatever kind of brick or clay or whatever kind of infill, that has a kind of an equality in its setting. So the main question to make separation between different ways of constructing something, it's either it's a skeleton structure, which then has some kind of infills. That's where I would take the hempcrete balloon frame as well, or it's a solid structure, which is then clay or concrete or bricks as a system. And these are all load bearing, while facades, as we educate them now, are non-load bearing, and by that they follow some equal geometries, but the main difference is not load bearing.
Yeah, and also within the typology, for instance, I wouldn't mention the filling as modern as hempcrete, as straw and clay, for instance, in the ancient times. But for instance, what's nice about the framing in here, the balloon frame versus the platform framing, which is the English against the German, sort of Dutch, maybe, describes how the load is transferred down and the building of this load-bearing structure is made. So therefore, that's very interesting because knowing about the balloon frame and versus the platform framing, you already understand how the loads are transferred within that wooden stick system. In a stick system, aluminium, steel, facade stick system, it's directly related to the curtain wall main typology sort of thing, what Uli already mentioned.
Yeah, I was going to say, to kind of wrap this point up, basically the stick system is a typology that's being discussed, right, in this course. There is another course that will be coming out in a couple months, theoretically, that's going to go over a lot of different typologies, principles, materials, and technologies of facades that will give you a better understanding of these definitions of stick system versus unitized versus frame system and stuff like that.
Yeah, precisely.
And don't get us wrong. The task for this course was to develop the storyline of detailing. Oh, yes, we do this with a stick system. Next course we're going to do is with a ventilated facade and a window. But it's about this is the way you detail. This is the way you do this process. And okay. Next question. Would a stick system work for an earthquake zone? Sure. It's a light structure, which is always good for earthquake situations versus, say, full concrete structures. It's a non-load-bearing structure, so the main function of a stick system in an earthquake situation is to not fall apart and to not let the glass drift off. Yep. So if you imagine a glass plate drifting off somewhere from the building, that's going to be harmful. Having it broken, all the small pieces, that's going to be harmful. So the main function for a stick system in earthquakes is to stay in position. And even if the building shapes differently, it's supposed to say keep the glass in position.
Yeah.
If
And-
you're
and-
if go on, I said.
Yeah, and we also have a border line from the insulation glass units to the walls of the stick system. They're in principle just clamped via the rubber joints, and they always have freedom. So in principle, you can bend, and the building will stay a little bit flexible in order to withstand the forces of an earthquake to a certain extent. But this is a very soft system.
And then, if you continue and think about, say, huge earthquake impact, and say next level of advancedness, you may change from a stick system to a unitized system, which then you would allow to even get loose as long as you have security anchors, like security belts, keeping it in principle in position, but allowing to get loose from the main building. So that even if changes of the geometry of the building appear, the stick system doesn't stay in position, correct? It's not tight anymore, but it doesn't fall down, it doesn't harm. That's the main job. So yes, in principle, this is something which we can use in earthquakes, but you have to take care of how you design it.
A lot of this stuff will also be explained later in the course when we talk to Erwin, who is he is a structural engineer, and he will discuss the movement allowances and tolerances that are required such that the stick system pieces will not bang into each other when the whole building moves or transfer loads through that system. Instead, it will go through the main system. The stick system will hopefully not experience those big loads.
Yep.
Yep.
Short question, Annabelle. We don't have any more questions on the slides.
No.
We can focus.
They come in the chat.
So we have another one that's interesting. In stick systems, is it feasible to use heavy materials like stone or brick panels instead of IGUs as infill panels? My first question would be why? But understanding the logics of a insulating of a stick systems is that you see that the windows as also the doors will have the same interface, means the same dimensions of isolated glass units, so 35, 50 millimeter max, for instance, that they could be clamped into your stick systems with a cover plate. Means whoever, it may not make sense to apply very heavy materials, but you may be able to apply the look of it, because you can also have very thin strips of brick that look like, and then if you make sure that the panels have the same dimensions roughly as an insulating glass unit, you can also clamp it into. For instance, that's the freedom I really like. You can do almost everything as an infill as long as you figure out that you have an overall parameter that runs around with the dimension of insulating glass units. I have glass fiber reinforced concrete panels insulated with a capillary water system on the outside and inside, invented during my PhD a little bit, and especially within my graduation, which was applied for a university building. Unfortunately, due to the risks you have with having 3 different components in one facade panel, no one of the contractors would have taken the liability for all of the 3 components, but you could easily put this into a facade stick system, and then you have a water sun collector and heating to the inside, for instance. So feel free to put everything in. Make sure your structural designers gives you a green light about the added weight. But if we nowadays deal with triple glazing, is already very, very heavy. So therefore, you could also put a little marble sheet and whatsoever in there. But often these are very thin, that they mimic, or that they are very, they look as massive, but they aren't, because they're supported by sandwich structures or so. Also have to be insulated. Uli, something else to
let's just go on to the next. Can a stick system be part of the supporting structure of a building? Yeah, it's defined to not be.
Yeah, you don't.
It's so no. The way we currently design our systems is we have a load bearing structure, and the facade is added on, takes the load the facade has to load, own dead weight, payloads, so person running into it, wind loads, things like this, but not the load of the building. That's how we design, which ends up that the systems itself are actually quite narrow, quite small. If you want them to be part of the load-bearing structure, that's a different story. Cut, yes, you can do specific designed settings where these structures can become load-bearing, but this is not the normal situation. So if you do so, you need to dig into the calculations of the systems itself and see what are the, say, the leftover performance parameters which you can maybe use, and you're then going to end up in maybe not an aluminium, but alternative steel version. And say the freeform steel version we did with Janssen, Marcel, for example, they now sell this as a skeleton structure for load bearing as well. Not load bearing the building, but load bearing, for example, a freeform geometry. But the main comment here is, no, this is not how it is normally done. If you want to do, then take care that you take the loads.
Yep.
And I'm very happy with that. Okay, good. Well, we get questions over questions.
I know. I think maybe we can take 2 more or so.
Yeah,
maybe 3.
The shading, yeah, we didn't talk about shading in this one.
Yeah,
it felt like it's a pity. It felt like being too much. Marcel, I'm currently trying to involve the shading into the next program, but that's another topic. And yes, this again, we talked with Alessandra in one of the later videos about shading.
Yep.
Essay you need. We also discussed the variations of an outer and inner and tinted glass version for the shading, but we didn't take it into consideration right now. Kinetic structures.
Maybe the question also within a stick system, that's what we haven't explained, but within the stick system, you can easily attach exterior sunshades. Due to the symmetrical layout of that, the screw channel that can be penetrated from the outside that also fix the cover plates, that's what we already shared with you in the drawings, can also, because the screws that hold down the cover clamps and the caps later are sort of 300 to 500 millimeters apart. Within every of this free spacing, you can insert anchors that go down to the very bottom of the profiles that secure a very strong mounting area for various substructures and or direct holders for sunshades. For instance, Schüco, we've been there. They already have fixed louvers that can mount to be like that. They also have various points where you can have Venetian blinds, for instance, on the outside, or fabric elements whatsoever. Even steel mesh, which later will be grown over by vines or whatsoever, could be possible. If it's a very heavy, if it's a very rigid structure, kinetic shadings, I don't have a picture of what you may imagine right now. You may have to figure out which kind of loads you have to deal with, and you may need to strengthen the facade for the exterior loads that you are able to carry these loads. Usually this is not an afterthought. It should be considered during the design of the building. If you have an exterior moving elements whatsoever high rise, that the additional loads will be also taken care of the mullions behind, because then you may deal with an unsupported structure that doesn't hold up to these exterior loads.
I think we maybe have time for one more if we're trying to keep it to an hour. And I think maybe we should answer the one that's leading into this next module about the selection of the details. So it says from Amir, it says selection of the details. The connection between the vertical and horizontal mullion was not called out as an area of detailed. I wonder why.
Yes, that's a very good question. That's actually a very good question. If I would say engineer is a stick system completely from the scratch. So I'm coming with the horizontal and the vertical, and they need to be connected. And then I need to secure that this works. But as we are dealing with systems, so we're not designing it ourselves, we're dealing with systems, we assume that, say, the connection between the one and the other is solved. So we refer to, okay, you go for this or this or this system, and each of these systems has the corner detail solved.
Mhm.
So I need to make sure that the horizontal and the vertical profiles I choose are having the same geometry. And then within the system, this corner detail is solved. If
The
I would go
supplier
for
system. The system from the supplier.
the system from the supplier, and
Yeah.
if I would go for different geometries for vertical and horizontal profiles, then I need to prove that within the supplier's system, this is either solved, or I have to, and that's where this question is correct, I have to design this detail. Here we made our choice kind of easy by assuming, okay, we go for a system, a full system, and we have same horizontal and vertical components. So we are expecting that within the supplier's system, this is solved as a setting.
Yeah,
But the question is correct.
I'm a little bit picky about how to understand the question, because I hope it was clear that we have horizontal transoms and vertical mullions. So therefore the question is already, I don't know exactly. And we have shown within the showroom of Schüco, for instance, how the horizontal transom is connected to the vertical mullion. So therefore, is there another area? I would like to see the sketch in which we didn't draw a circle of attention in order to define the areas of that we would like to describe in detail.
No. Marcel, we only cut horizontal and vertical. We do not draw the corner itself.
Ah, okay.
It's about the corner.
Ah, okay, the
that
corner.
person is right. If you think about something entirely new, you need to think of the corner. Well,
Yeah,
that's
of course,
correct.
of course. Yeah, of course.
But here, as we use both systems, both profiles the same, and we expect that within the supplier's system, the corner is solved.
Yeah, we may also have to tell that by choosing a system, you are already freed a little bit about additional thoughts. What we have described is in principle the translation of an architectural demand into a construction drawing. It is not the course how to develop a stick system from scratch. We have used the details from Schüco in this case. Could be also Varema, could be Reiners or others in aluminium. They're almost the same, with the little bit of differences of each of the fabric of the manufacturers. But of course, yeah, they all have a little different things. But this is more the translation of the general work by picking a system and then following its rule book, which is big. No? It's back then we had from 3 different companies the system books overview for the manufacturers, which was already a full, I would say 10 square meter bookshelf full of things. This was incredible. I love this detailed level, but it's almost impossible to know everything of that. That's also why often the companies changes also
and constantly changes. Huh?
Precisely.
Okay, Annabelle, I think we're done.
Yeah, I was going to say thank you, everybody, for participating. And any of the questions that were not addressed, I will save in the chat and we will post along with the recording of this video some answers to those. And then, I guess
we meet again in 4 weeks, isn't it?
Yes, there will be another webinar in a couple weeks.
But I think in 2 weeks or so already.
However, okay.
2 weeks.
2 weeks. Great.
So with that, thank you.
Perfect.
Yeah.
And thanks for organizing, Annabelle. Thank you.
I will say thanks. I will stop recording and we will share the file within the next couple of days via the platform.
Excellent. Perfect.
Perfect.
All right. Well, thank you.